Scientists are finding things in the newest James Webb Space Telescope images that nobody expected. Discoveries that are so strange, they're forcing us to question everything we thought we knew about the universe, from dark matter and dark energy to even the Big Bang itself. According to experts, the Webb telescope might be uncovering something revolutionary, something that could completely rewrite our understanding of how the cosmos began. Dr. Andrei Kutau, a postdoctoral researcher at the Lawrence Berkeley National Laboratory, said,
"We're in the business of letting the universe tell us how it works. And maybe it's telling us it's far more complicated than we ever imagined."
So, let's break down these mind-blowing discoveries, step by step. The mystery that started it all. According to the laws of gravity, its strength weakens with distance. The Sun pulls on Mercury much more strongly than it does on Pluto. This law holds true across the entire cosmos. But in the 1970s, astronomer Vera Rubin noticed something strange while studying galaxies. Stars far from the galactic center were moving just as fast as the ones near the middle, which should be impossible. If gravity gets weaker with distance, the outer stars should have flown off into space, like water spinning off a wheel. Yet they didn't. This led scientists to propose an invisible glue, dark matter, something unseen that holds galaxies together. It became one of the central pillars of modern cosmology. In the deep universe, Webb has found galaxies at unimaginable distances, farther and older than anything ever seen. The deeper it looks, the more galaxies it finds, as if the early universe was already packed with fully formed galaxies only a few 100 million years after the supposed Big Bang. One of these, MAX 114, existed when the universe was just 280 million years old. Others, still unconfirmed, may have formed when the cosmos was barely 200 million years old. Even more shocking, some of these galaxies are massive, organized, and even spiral-shaped, like our Milky Way. One, known as JWST, is nearly 10 times larger than the Milky Way, and it existed impossibly early. According to the dark matter model, galaxies should have taken billions of years to grow this large. So how did they form so quickly? Either we've misunderstood dark matter completely, or it doesn't exist at all. It's not just the galaxies. The largest structures in the universe, the cosmic web of filaments and galaxy clusters, also seem off. Scientists use something called the S8 parameter to measure how clumpy matter is across the universe. When calculated using data from the early cosmos, such as the cosmic microwave background, CMB, they get one value. But when measured using modern galaxies today, they get another, consistently lower value. This mismatch is called the S8 tension, and it's become one of the biggest puzzles in cosmology. It's as if the universe we see now doesn't match the one predicted by the Big Bang model. Then comes the next shock. Dark energy, the mysterious force believed to drive the universe's accelerated expansion. For decades, scientists thought it was constant, always the same strength. But Webb's new data suggests it might actually change over time. That means the universe might not be expanding in the way we've believed for nearly a century. Even worse, when we calculate the universe's expansion rate using two different methods, we get two completely different answers. This is known as the Hubble tension, and it's one of the clearest signs that something fundamental is wrong with our model of the cosmos. The cosmic microwave background, the faint glow we've believed to be the leftover radiation from the Big Bang, is now under fire. A new study suggests that this ancient light might not be a relic of creation at all. Instead, it could be the combined glow from the first generations of galaxies filled with hot young stars. Over billions of years, their radiation could have stretched and cooled, mimicking the same background glow we've always associated with the Big Bang. If that's true, the entire foundation for the Big Bang theory could collapse, because the CMB has always been its strongest piece of evidence. Imagine, what if that light isn't from the birth of the universe, but from something that came much later? But the mysteries don't stop there. In one of Webb's largest galaxy surveys, over 30,000 galaxies, scientists found that most of them are rotating in the same direction. That shouldn't be possible. According to the Big Bang, the early universe was chaotic. Galaxies should spin randomly, but they don't. The further back Webb looks, the stronger this strange alignment becomes. It's as if the universe itself had an initial spin, a cosmic rotation embedded from the very beginning. After all these findings, some scientists are suggesting something radical, that our universe might be inside a black hole. According to researchers at the University of Portsmouth, the universe may have formed when a massive star collapsed, creating a black hole whose interior became a new, expanding universe. Ours. In this view, the edge of our universe is the black hole's event horizon, a boundary beyond which we can't see. This theory challenges the idea of a single explosive Big Bang. Instead, it proposes a cycle, where each universe is born from the death of another. Nobel laureate Sir Roger Penrose supports a similar idea in his conformal cyclic cosmology, where each universe, or aeon, ends in emptiness and gives birth to the next, meaning other universes existed before ours, and more could come after. With every new image from James Webb, the universe grows stranger, from galaxies that formed too early, to cosmic alignments that shouldn't exist, to a background glow that may not belong to the Big Bang at all. Everything we thought we knew is being questioned. It's becoming clear that the cosmos might be far older, far bigger, and far more mysterious than we've ever imagined. We might not be looking at the end of science, but the beginning of a whole new understanding of reality itself.